Hello, and today we're going to be talking about capacitors in DC circuits. So capacitance is the ability to hold charge across an electric field, and so when you have two parallel plates with one positively charged, one negatively charged, the electric field is going to go between the plates, and that's going to be able to store energy. So the capacitor is the actual electrical device that we use, and by increasing the surface area, using a dielectric, which is a material that you insert in between the plates that is electrically resistive, and by decreasing the distance between the two plates, we can increase the capacitance. So unlike resistors, a capacitor does not dissipate any energy, and it will actually instead store that energy in the form of an electric field. And then when the capacitor is finished charging and goes to discharge, it will release that energy back into the network. And the formula is W equals half CV squared with units as joules. So when we're talking about series and parallel circuits, they're opposite to resistors, so the way you add them up for resistors in series, you do that for parallel with capacitors. And in RC circuits, that's just a circuit that has resistors and capacitors in it. When we're talking about steady state and time constants, the charging and discharging of capacitor is actually a time-dependent thing. So after about 5 or 6 time constants, then the capacitor is going to be fully charged for all practical purposes. And so to work out what one time constant is, that is what the resistance times the capacitance is with the units in seconds. And once we're at steady state, that means that the capacitor acts as an open circuit, so no current can go through, but voltage across it is at a maximum. These are the 4 equations that you'll be using. Note that the discharging and charging, they're actually quite similar. So discharging for voltage is the same as charging, but without the 1 minus. And the discharging for current is the same as the charging for current, but has a negative instead. So we'll just have to quickly run through some worked examples. So for this one, we're to write an expression for the voltage and current for the switch in the first position. So that means we've got the 140 ohm resistor and the 47 microfarad capacitor. That way we can work out the time constant to be 6.58 milliseconds. Then we just have to sub that into both of the formulas. We're subbing in E is 12 volts, which is our supply voltage, and R being the 140 volts. So the second question is, after 40 milliseconds, the switch has moved to position 2. So the little trick with this question is, because the switch has moved, that means we've got to recalculate the time constant, this time using the 50 ohm resistor. So that gives us a time constant of 0.00235 seconds. And again, sub those back into the formulas. And note that E is still 12 because 40 milliseconds is after 5 time constants for the original time, which means that the voltage across the capacitor went up to 12 volts, and now we'll discharge back into the network. Thank you.